So this talk is called Feed Your Inner Data Scientist, JavaScript Tools for Data Visualization and Analysis. Our goals today are to take the data that we collect from a variety of sources. Data can come from health, government, financial, or DevOps operations. And it also can be given to us through IoT, sensors, or statistics. So we're going to take that data and then somehow get it into a form that's usable by our users, which will be the analyst. A little bit, I'll go back if you're taking a picture. Okay. A little bit about me. Again, my name is Doug Mair. If you want to contact me, you can contact me through Gmail, doug.mair@gmail.com, or at Doug_Mair on Twitter. I tried to get the Doug Mair without the underscore, but somebody had taken that. I've been promoted since I wrote that abstract. Now I'm a director of consulting for Improving Enterprises, and I still continue to host the Windows Developer User Group in Columbus, Ohio. Windows has expanded its focus, obviously, with Azure, and so we pretty much cover anything that runs on Windows, which is pretty much everything. So that's what we focus on. We meet third Monday of each month in Columbus, Ohio. It's a fun group. So what is big data? So as I mentioned before, we have all these processes that are delivering lots of data to us, and there's so many, it's in the petabytes of data every day that's being generated. This is way too much data for us to understand. We need tools to help us collect the data and then interpret the data. And it's vital to have a separation of concern. So when we're processing the data and we want to pull it in, these are things that we can do on servers in the cloud, for instance. We're going to get the data and put it on the cloud and just process it. The client computers, these are the computers that sit at people's desks, should do as little work as possible. The beefy machines are going to be our servers that are processing the data. So we want to deliver the data in a format that is usable by our client machines. I'm not going to talk too much about how to collect the data, but I will say that there are services and event queues are good architectures to explore if you're on that side of things. I know data scientists spend, I'll say, in the range of 80% of their time just getting the data correct. And once they have the data correct and aggregated correctly, that the rest of the time is the analysis and then the visualization for the user. So this is, I'm not going to talk about it, but it's a vital, important role that the data scientist does. So before we go too far, I brought up this picture. Can anybody tell me what this picture reminds them of? This is a question out to the audience. A graph? Okay, yeah. A graph of what, though? What might we be looking at here? Stars? Yeah, like the universe. So maybe some sort of gravitational waves or something like that. Any other thoughts about what this might remind you of? Neurons, like activity in the brain. So it could be a map of activity in the brain. Any other thoughts on this? Yeah, that's a good one. Those are the three that I hear most often. So these could be flight paths through major cities. So by looking at this, we could tell that there are locus of interest, that a lot of these paths are going here, for instance. A lot of paths are going here and here. So there's something important about locations like that. If we gave this to our user and said, just hover your mouse right here and you'll get all the information you need, they would not be very happy with that. We could tell that there's a lot of data that's contained in this image, but we don't know how to get it out of this image. It's kind of daunting and overwhelming. But it gives us hope that we're going to get some data out of this. The way that we get the data out of this is using operations such as MapReduce. And I want to describe, a lot of people may know what this is already, but I want to take the time to describe it so that we're on the same footing. There's two sides of the MapReduce. The map side is where you're taking and your data, your volumes of data, and you're grouping it, sorting it, and filtering it. So, for example, you might take all your stock trades and split them out by company, date, or time. So you've taken all the trades and you've put them into different groups. I like to look at this as putting the data into buckets. So you have a bunch of buckets that you've designated, and you're splitting the data out into those buckets. The great thing about this operation is it can be massively parallelized. So you can have lots of servers taking data and putting it into the appropriate buckets. The other side of the equation is the reduce. Once we have the data in those buckets, these are the functions that we're going to apply to those groups of data. So examples of those functions might be to count the items in that bucket, to take the sum of the items in that bucket, or to take the averages. MapReduce will come up later in our talk, but I wanted to introduce it before we get too far. So on the reduce side of things, this is where we have algorithms and math that is going to be unique to our company. This is going to be the special sauce of our experience. So a lot of this data is widely available to many people. It's how you operate on that data that gives you an edge up over your competition. And this is usually the top secret stuff that gives you that edge over other people. So I found this on the internet, and I thought it was a good example of the MapReduce operations explained with emojis. It's at this website. So the map operation, we have cows, potatoes, chickens, and corn, and we apply an operation on them called cook. This gives us 4 different buckets. So one bucket is hamburgers, French fries, chicken again, chicken becomes chicken, and popcorn. At this point, we can decide to filter our stuff for, let's say, a vegetarian. And at that point, these 2 buckets appear. I do want to make the point, though, that at the point that we did the cook operation, we can no longer see the individual cow. It has become a hamburger. And so that association between the detailed data to the individual bucket has been, in our case, lost. It doesn't always have to be lost, but in our case, it's lost. So at that point, we could also do a reduce operation. So we take all the things, hamburgers, French fries, chicken, and popcorn, and we can apply the operation of eat. And once we do that, we can produce and sometimes poo. But hopefully, our data is better than that. We want to produce actually valuable data. Another way of looking at this is with, let's say, a stock data set. I don't want you to be able to understand all this. There's a lot of data, and just imagine this goes on for pages and pages and pages. It's kind of an eye chart on purpose. On this side are the things that we have determined are important. So we create these buckets. So we have a bucket for October, September, and August. So all the rows over here that had October go into this bucket, and September and August. Now, the reduce operation, so that was the map operation, taking those things and putting them into the buckets. The reduce operation is performed on everything in that group. So for our reduce operation, we're taking the average hot open, the low, the high, the average close, and the total volume. You can have many reduce operations. You don't have to have one reduce operation. And you can store the results of all those reduce operations. So I have a question for you. Looking at this data here, can anybody tell me which company had the highest stock value for a month, for, let's say, September? We can't see that in our data. The name of the company was not even in our data, so it's kind of a trick question. We have aggregated our data. Can we also tell which day had the most activity? Again, this is another data that we chose not to put on this side. So the answer is you have to be very careful on how you reduce and map and reduce your data so that you gain or continue to have the information that's important for you. And this leads to the point that it's a very iterative process. So if we were in a perfect world where internet's operated at full volume, we could get all the data down to the client computer, and the client computer had infinite resources, we wouldn't have to worry about this. We could just take all the data and then process it immediately. But since that's not the case, we have to be very careful in this balance of the number of details that we're collecting and the size of the data that we want to send down to the client. So clients, we want to keep our, if possible, data size in the millions, not tens of millions of rows. Try to keep it into a manageable size of data. So we might have hundreds of millions of rows that we're going to condense down into millions, maybe tens, but try to keep it under tens of millions. So that's the background of MapReduce, and all of a sudden, a business requirement comes to us. And it came on the back of a napkin. Somebody was talking to somebody else, and they want to get a bar chart of the data that is available. I did want to make one more point on this slide. Since we have this constant iteration of the data and the size of the data, the details and the size, we have to architect our system for iteration. So that means we have to architect it in such a way that it's easy to change and it's ready to grow. We also have to architect the data visuals for the same change and growth. So with that in mind, we get this requirement, and they want to have a bar chart of the data that we've been collecting. So at this point, our minds go crazy. We have options here. We can generate a chart on the server side and then send up a PDF that we can embed in the page. Nothing wrong with that way of doing that. That's the way things were done several years ago. We could do it in plain old HTML and CSS, or we could use a tool called D3. So these are, and there are more options than that. So let's start with our very first example, and that's going to be with HTML, CSS. So, oops. Okay, here's an example of an HTML site that's running on my computer, and it's running live on my computer. We see that there's data, and it's meeting the requirement that they gave us. These bars are horizontal. We'll fix that later. But right now, they're working. It's meeting the requirement. So let's look at how that code is written. Okay, so people familiar with HTML here? I'm sure pretty much everybody is. So I won't spend much time on this, but the basic thing is we have a style that we're going to apply to every div within chart. So down here we have a div called chart, and all of those divs get this style. So great, we have our data hard-coded here. But if you notice, if we want to add a new row, we have to physically go in here, add a new row, and then we have to do the math ourselves. So it's not very friendly for the developer. We met the, this is the way you do kind of TDD. You meet the test as quickly as you can, and then you improve it from there. So we met the initial requirement, but there's going to be more. So as I showed, the code is it's functional, but it's boring, it's inflexible. The math that we had to do was manual, which I don't like. Every time there's a manual math, you're going to mess it up at some point. And it's non-interactive. We'll get to what interactive means later as we go along. This example came from Mike Bostock's website, and it's just a simple bar chart, as we showed. And I showed that if we wanted to add something, we had to cut and paste, so it gets kind of tedious. There's got to be a better way, and this is where D3 comes in. D3.js is a JavaScript library for manipulating documents on data. It stands for data-driven documents. It uses HTML, SVG, and CSS. So we haven't talked about SVG yet. We talked about HTML and CSS, but there's a new thing here, SVG. If you've used jQuery, D3 is in the same conceptual realm as jQuery. It's not trying to replace the DOM. It's trying to work with the DOM on your data. And so it's a data-driven approach to DOM manipulation. So we're not trying to replace the HTML DOM, we're trying to work with it. And you can go to d3js.org to see more details. So let's see how we would have done the same thing that I showed you using D3 instead. These examples are going to start out pretty basic, and then over time, they'll get more interesting. So okay, here's the same exact thing now with D3 as the driver. And again, it's from Mike's page there. And I'm going to switch to that. I'm using VS Code, by the way. It's one of my favorite editors. Okay, so this is the D3 way of doing the same exact thing. We start with the same chart. Again, we're not trying to replace the DOM. We're working with the DOM. And then our data is right here. This is a huge step forward. Now our data is a JavaScript array. Before, it was hard-coded in the divs. Now it's right here. It's easy to add an item if I want to take something away. Like I took 39 away, I'll save it. Sometimes I forget to save. And refresh the page, and the 39 should be gone. Magic, okay. So yeah, it's data-driven. So here's the data, and this is the part that's doing the actual work in D3. So we start from the chart, we select the chart item, and then we're going to create new divs. That's what this section here is on the enter. Oops. My mouse, oh, there we go. We're going to create new divs here, and those divs are going to have a width based on, and here's the math. I don't have to do manual math now, which is another huge advantage. Just by adding D3, things got much simpler. I'm still using divs. I haven't switched over to SVGs, but eventually we will. So much better, but there's going to be more. How many people are familiar with D3? Raise a hand. Okay, a few people. Hopefully my Wi-Fi works. It worked earlier in the day. It looks like it's working. Okay, good. It's downloading now. This is a gallery from the D3 website. So I'm going to start scrolling. And you get a lot of great, interesting pictures of visualizations that you can create on D3 website. I'm going to switch over to scroll with the arrow. That just keeps going and going. So pretty much anything you can think of, somebody has done this. And then, so these are the visual examples. On any one of these, I can click in here and see the source code. If it worked, yeah. So there's an example, and this one doesn't have the source code, but I would say 90% of them actually have the source code for how to generate these things. So there's more and more, and then we get into the section where there's more of the tutorials. So these are pages that you would go to and then start looking more in depth about how they're going to give you a walkthrough of how they created it. And this goes on and on too. So I wanted to take the time to show you all that because I actually sat down and it counted. I counted at the time, let's say 2 months ago, there were 340 visual examples that you could go to and get source code very quickly. Or there's 600 plus links to even more tutorial type examples. So close to 1,000 examples that you can get very quickly. The approach with D3 is look for a chart that is close to what you want to create, and you will probably find a working sample in this gallery. And then once you find that sample, change it to use your data instead of D3's data. So I want to highlight a few of the interesting examples I found on D3. One of them is a force layout chart, and then a cartogram. So let's look at the force layout first. That's right here. And by the way, if you have questions at any time, feel free. I'll try to keep an eye out for questions. So here's the force layout chart running on my computer, and I have it zoomed in a little too far. So I can do things like take an item and drag it around. I can hit the button that scatters them all around. I don't want to give you the impression that D3 is a gaming engine. It has animations, which is awesome, but it's not a gaming engine. There are better tools for gaming if you want to use a gaming engine, but it does have some really neat visualization tools. Let's look at the source code for this. Did it open up? Got the file open there. Okay, so here's the force layout. I'm not going to go into all the details of this. There's a line here which they include D3. I happen to have it on my computer. You can have it on a DSN or CDN. Yeah, no problem. And then we get into the actual script. So I'm not going to go into the details of this, but just to say that that was 74 lines of code. So not a whole lot of lines of code. That includes the data of creating them and visualizing them and all that interaction. So pretty impressive. For 70 lines of code, you could have a force layout chart. Let's look at now the topo chart. Okay, so what this has done is based on some statistic, it changed the size of the state based on some statistic. And I don't know what that statistic was in this case, but you can see that there's states of different sizes. So let's look at how much code, or the coding that was involved in creating this. And by the way, there's no interaction on these. I've also seen on D3 charts that if I clicked, I'm from Ohio, so I always gravitate towards Ohio. If I would click Ohio, it would expand and show me all the counties in Ohio. This chart doesn't do that, but there are samples that do that very thing. Yeah, definitely from Cincy. That they're spreading out. Is it just regional, or has it gone beyond regional? Oh, great, yeah. Skyline Chili. So here's the code for that topo chart. So we get into the data for each state. That's this section right here. And then they had an include right here of D3, like we had before. Then they bring in the data for the topo JSON. This is kind of a cheat. I'm going to show you it's only 60 lines of code. But this topo JSON data is the paths around the states, each one of the states. So that's the type of code that's going to stay the same no matter what your data set is. So I'm not including that in the count. If you wanted to look at that, that's under the include directory here. Let's see. Oh, right. No, here it is. And it's minified, of course. So it's not going to be very helpful looking at it in a minified version. But I could word wrap it. It's, yeah, kind of dense code here. What's that? I don't know, couple K worth of code. But anyway, it uses the data in this USA JSON file, which is a whole bunch, all of the paths, sorry about that, all of the paths for each state. Now, if two states share the same edge, it only stores it once. So there's some smarts involved in this, so that it has all the edges, and then the states have sets of edges, for example. So all of that was just to say that there are lots of great examples on D3 of how to do very interesting things. So back to our bar chart. We want to make it better. The first one we had, the bars were horizontal and not too exciting. We were able to automate the data, but now we want to make it better. So let's see how we would make that better. Here's the bar chart, and you can see the mouse moving around. Let me make that a little bit bigger for you. Whoa. I'm clicking on the bars, nothing happens. We wouldn't expect that to happen yet, but that is an interesting thing that we could try to do later, have the bars do something when we click on it. But now we have axes. It's starting to look more like a bar chart that we could give to somebody and be proud of. So let's look at the code that's involved in this bar chart. Close some folders here. Okay. Again, we're going to have styles that are set up that we're going to use throughout. We include D3. Now, JavaScript is a functional language. JavaScript is a lot of things. It's probably too many things all in one, but one of the powers of JavaScript is it's a functional language. So what we're doing in this section is declaring functions that are going to be used as it's processing the data. And here's another function that we're going to use as we parse the date, for instance. So we're setting up these functions that will be used as we get the data. Here's the section where we actually get the data. D3 has a method called CSV that I can give it an endpoint or an actual file. It'll go and read that file, and then once it has successfully read the file, it'll call this function. This is the typical pattern that you see in JavaScript. You have a method that takes some data and runs a function at the end. So this is asynchronous. So if there was an error, it would return the error. If it was successful, you're going to get data in this data element. Now this is very important for JavaScript and probably any language that you're in. You want to make sure to validate your data and clean up your data. That's what this first section is for. You always want to do this. So for instance, the date that we got might have 1/1. That's not that's not a date at this point. It's a string. So we're going to call that parse date function that we described up here. Right here, that's the parse date function on the date that we got in the data. And then even numbers, you have to by putting the plus on it, that tells JavaScript this is a number. Otherwise, it's going to keep it as a string. So here's some of the code that's going to generate the x-axis. I'm not going to go in details on that. Here's the code for the y-axis. And this is going to do the labeling and everything. And then we get into the actual bars of code. That's going to use the data. It's going to enter. It does a select, enter. And if you need to remove items from your chart, that's where there would be an exit sign, exit method. We don't need to remove anything. We're just adding. So it's not too hard to read. And let's also note that we've moved into the SVG space at this point. So we're going to look, we're going to start at the bar element, and we're going to create rectangles now for our data. So this is a rectangle, and this is a key point to remember. When you're working in D3, you have to think like the item that you're attacking. So when we were using HTML, we had to think like an HTML processor. Here we're using SVG. We have to all of a sudden start thinking as SVG. So SVGs have recs. Recs have a fill color. They have an X and a width and a Y and a height. So using the data that we had, we can calculate all those things. That's what's happening here. So I just want to drive home the point that in D3, you have to think like the target that you're targeting, which isn't terrible. As I showed you, there's 600. Oh, sorry. Sorry about that. Okay. How long was that? Like a couple seconds. Great, thanks. All right. So yeah, again, if you're in the SVG space, your mind has to think like an SVG processor. So that's much better, right? As I said, I would be proud to put this out in production. It's going to change as the data changes. We have axes. It's interesting now. One thing we're missing is interaction. You know, how can people use this? There's another tool that is on your description of this presentation called DC. And I want to talk about what DC is real quick. We'll go into much more detail later, but let's see how DC handles the same thing that we just did. So here's the DC bar chart. I want to have it running first to show you. Okay. So now I can move around on here. You see some interaction starting to happen. And I should get a tooltip. I can click on them, and they highlight the one I'm selected on. And there is a tooltip. Let's see. The mouse moves. Let's see. Nope, it's not showing up. Anyway, there should be a tooltip. So this is better. And let's see the code that was required to create this. So that's the DC bar chart. DC requires a thing called CrossFilter. It requires D3, and then I'm using Moment.js. If you do any JavaScript programming using dates, I highly recommend Moment.js. It's a great tool for date processing. Dates did not come as part of JavaScript. If you try to do without using Moment, you've got a lot of work to do. So again, we have the D3 call, which is going to give us our data. We clean up the data. Then we create this thing called a CrossFilter index. From the CrossFilter index, we can start to pull off dimensions and reducing operations. So this is the actual code that creates the chart once we have our indexes created. And I'm trying to fit it on one page. So it's, what's that, 15 lines of code? The thing about DC is we're operating at the chart level. We're not operating at the line level. When we were in D3 space, we had to draw individual lines. Here, we tell the chart how to respond. So we tell the chart that you're this wide, this high, you're using this dimension, this group, and then basically, once we do all that stuff, we say chart render yourself. So it's a much more readable format. And I do want to make the point, I am not dissing D3 in any way. D3 is great for many, many different varied visualizations. If you have visualizations that are business-based, there's about 30 of them, and I'll show that later. DC is a much better option for those 30. And you get some other benefits too. So that was the DC bar chart. So let's imagine that all of a sudden our requirements change. The clients were happy, but they say, we'd rather see it as a line chart than a bar chart. So how would we do that using D3? Here's the code for the line chart, and the site is right here. Okay, so this is, we ran the code and it created a line chart. Okay, interesting. But how the code is pretty much the same except for when we get down to this section right here that I have highlighted. Since we're thinking in D3, now we have SVGs that we're thinking about, we have to think about a thing called a path. And the path has a line which has D elements. It's a collection of D elements in SVG. So it's a whole different way. Before we had rectangles that had width and length, and so it's not terribly complicated, but it's not super simple. Now, if we did the same thing with D3, all we have to tell D3 is make a line chart instead of make a bar chart. So just to drive home the difference here, that with D3, we're thinking at the individual element level. With DC, we're thinking at the chart level. So the clients are happy, and but they're so happy they want to buy more business with us, which is a great problem to have. They want to have a dashboard now. And so what is a dashboard? This is where we're going to introduce multiple charts that begin to interact with each other. And again, we got the paper napkin that tells us what we need to do. So let's see that running on the web page. Okay, so here's the dashboard. We see all of the salesmen, and we see the volume and the individual items. This is for all of the salesmen together. If I click on Sam, now I just see Sam's data. If I click on Peter, I see Peter's data. Well, I can't click on both at the same time with this implementation. And if I want to reset back to everybody, I have to refresh the page. But it is pretty cool that we have now some interactivity between charts. There's no interactivity on this side, on the number. The number's just a static thing. But there is interactivity on the charts, so that's pretty cool. Let's look at the amount of code that was required to create this. Now this is kind of picking on D3 because it's not really built for this type of thing. And I think it's reasons like this. People built dashboards using D3 and started to notice, hey, we're doing the same thing over and over again. Let's pull all these things out and make DC. So after doing a bunch of bar charts like this, they decided, let's abstract some details here. So this is a 794 line file to generate that dashboard. And if I search, there's different sections here. Like here's the pie chart section, everything that's involved in the pie chart. What you'll notice is there's a lot of great code in here, but the data is also in here. So the data for the pie chart's in one section, the data for the line chart's in a different section, but they are interacting together, which is kind of a mess if you ever have to go and fix something. You'll have different data sources that you have to supply data to, which is, hopefully you're seeing that there's a lot of custom code, but it's driving us to a point here that there's a better way to do this. So that was pretty good. That was awesome. And this is where DC really shines. DC is a dimensional charting JavaScript library. So it's built on top of D3, and it adds this ability called CrossFilter. You can find DC at this website. It's at github.io. And I will say that this community that maintains DC, very active, anytime I have had an issue with this, they answer the question and get me going very quickly. And usually, they're also on Stack Overflow. Usually, if I had an issue, somebody else had asked the same question, and I just reaped the benefits of already having the question answered. It's got a fluent interface. So we'll talk about that as familiar with fluent interfaces here. This is kind of DSL talk. So you'll have a method that takes in an object, and it returns the same object after performing operations on that object. And it passes that object down the line of these method calls, which is very, in my opinion, very readable, but you have to be careful. Sometimes these fluent interfaces, if you mix up the order of your methods, different things can happen. So the order of the methods is important, and the return types as you're going through there is also important. I'm getting a little tight on time here, so I think I can show you DC running on my browser. I think I have time for this. I took this from the DC web page and put it onto my computer, and you'll notice there's lots of different charts going on here, which is cool. These are stock operations between the years of, it'll show down here, 1996 to 2012. Now, the great thing about this is I could say, I want to see what happens on Q1 and Q3 on Mondays and Tuesdays. So very quickly, I've filtered my data. I can hit the reset button, which goes back to all data, right here. Now I'm back to all data. So I don't have time to go into it, but this is about 600 lines of code. And again, since we're in the DC space, we're working at the chart level. We're taking these charts and we're tying them together using CrossFilter. So hold on a second. CrossFilter is the thing that is doing a map reduce operation on the data in the browser. And DC leverages that map reduce for these charts. You say, I want this dimension on this chart, this dimension on this chart, and it does the cross-filtering into the browser. And this is where I would say millions of records are doable at this record with DC, millions of records. I would not go to tens of millions. You're going to be pushing it if you go that far. Here's an example of how you set up CrossFilter, which I don't have time to go into. And then I showed you the CrossFilter dashboard. It's very awesome. You can go to DC.js, do a Google search for it. You'll see the same dashboard. And here are the chart types that are available for DC. Anything out of this realm, D3 is the answer. But if you're in this realm, DC is a better. Another thing here is if you need to do data tables, there's a great datatables.net. And thank you for listening. And sorry about the technical difficulties that happened. Thanks again.